Good morning, everyone. In the last session, we discussed about the is alive method, so which is coming from the third class. So today we are going to discuss about the another important concept to call join method. So the differences between join method and is alive method, what it will do. So today we are going to discuss about one of the another important example here. So basically, whether the particular thread is in the active status or it is in the terminated status, now what we will do, we'll try to call this particular method on top of this particular thread object here. Okay, so if it is in the active or if it is the terminated status, so we are going to get the appropriate information here. And now what I'm doing here, sorry, I'm not going to run this particular for loop here. And here, what I will do, I will try to use the join method. So using this particular join method, what we can understand basically, so now observe carefully. Explicitly, I'm trying to call this particular join method. How I'm able to join this particular, how I'm trying to call this particular join method. So now you can see the join method, it is not a static method. Thread dot join. So right now, we don't have any join method with a static behavior. Getting the pen. So we don't have any join method with a static behavior. So still we are getting an error. Now if you see a thread one dot join method. Getting the pen. Thread one dot join method. Now you can see. So basically, if I want to call the join method, we need a object here. We need a object here. Now what I'm doing here, I'm trying to call the thread one object to join method. I'm trying to call thread one object to join method. And whenever I'm calling this particular join method, internally what happens basically, whenever we are trying to call this particular join method, so it's going to wait until the current thread to terminate here. Getting the point. So until this particular current thread to terminate here. So it's nothing but whenever we are calling this particular join method on any object, the particular object will terminate here. Until the termination of this particular current thread, the join method will wait. Okay, so this is important. We need to understand the purpose of this particular join method. So sleep method. Right now we discuss about the sleep method. So what we need to understand this particular sleep method. Sleep method, whenever we are trying to provide some certain time here. So once the time is completed, it will come back to the normal state. It will come back to the running state, and it will try to print all the values here. Getting the point. But here what we need to understand basically, whenever we are trying to call this particular join method, so join method cannot take any parameter like the time duration parameters here. So what happens internally, it's going to wait until the termination of this particular current thread. So whatever the thread we are going to call, basically the current thread, until the termination of this particular current thread, join method will wait here. Okay, so this is we need to understand. Now I made as the thread one dot join here. Whenever I'm trying to call the same example, now observe carefully what happens internally. So here we need to understand. So here what happening, the three threads, whatever the three threads we are having, all this particular three threads, basically it is trying to provide the true value. So initially this particular three threads are in active status. These three are in the active status here. Okay, now whenever I'm trying to come down here, now you can see all are in the false status. So again I'm going to run. So before going to run, now what I will do, so we are calling the extend thread here, and here I'm making only one time here. So I don't want to repeat these many times here. Okay, so only one time I'm repeating the for loop here, so that we can easy to understand here what are all the values we are having. So one more time, all the three threads are in the false status. So again I'm going to run. Again I'm going to run. Now you can see at this time, so I'm expecting the yesterday result here. Whatever the yesterday result we had identified. So like whenever we are trying to run multiple times, so the each iteration is basically, so sometimes we may get true values at the end of this particular, at the end of this particular is alive method, it will return true. But here this particular thread one, whatever the thread one we are trying to call here, the particular thread one will not give the true value never, because what happens if, what happens this particular join method, so this particular join method internally it will try to, it will try to terminate the current thread. So whatever the current thread we are having, the current thread will terminate here. Getting the point? So this is very important, we need to understand. Okay, so whatever the current thread we are having right now, thread 1 is our current thread. Now what happens internally, the current thread internally it will try to terminate here. Okay, so same way if I'm going to call this particular thread 1 and thread 2, thread 3, thread 3, so these are all the three threads. So whenever, how many times you are going to run, every time you will get false here. Every time you will get false. You are not going to get a true option here. Getting the point? This is important here. You are not going to get true option here. So why I am not going to get true option? Because internally, what happens internally, this join method. So based on the object here, whatever the object we are passing here, based on this particular object, it will try to wait to terminate the current thread here. Getting the point? It will try to wait to terminate this particular current thread here. Okay, so this is, we need to understand very carefully here. So any questions regarding this particular join method?
Sir, is there any way to see whether the next thread is in the waiting state kind of thing? We cannot see that. Or is
No,
there
there is
any?
no relation. Basically here, the all the three threads we are like whatever the this object we created here, so they are trying to run simultaneously. So there is no
Then,
information to identify, because all this particular three threads will start at a time here. So we don't know, like within the milliseconds of time, these threads are going to execute it here.
okay, join means first thread one will start. Until that, the
No, no,
other
no.
thread has to wait, right,
See,
sir?
basically, this is the different, because here we are having the three objects. What happens here?
Mhm.
Whatever the thread one is going to start this join method, same way it will try to start the other join also. But internally, whatever the object we are passing it, this particular object it will try to terminate here. But until this particular termination of this join here, the another threads is not going to wait here, because all these particular three threads are going to run by the main thread here. So just it will call the method here, and internally it will do the operations. So whenever I'm trying to click here, now you can see internally. So we are calling join 0. So it is a synchronization. Now here you can see one by one thread will allow here. Because of this particular synchronization, internally it is trying to hold the one by one. So how many threads we are calling basically here? Here it will wait. But outside, the main method will call all the three threads one by one. So it's not going to wait basically.
Oh, okay.
Okay. So any other questions? So otherwise, what we can do, I'm going to put a breakpoint here. Now we'll run the same example one more time in the debug mode. So now you can see this particular values are printed by all the threads here. So one thread is value 0, second one is 0, and third one is also 0. So if I'm going to print this, if I'm going to see the instructions here, now you can see all are in the false status. What about this particular? So this is also in the false status. So why it is in the false is basically because whatever this particular loop we are executing, that is completed. The run method is executed. So now what we can do, here I will put the breakpoint here. I will run one more time. Now okay, now you can see these are all the threads. First thread here, second thread here, and third one. Now you can see this is the right side, sorry, left side here you can see. So thread 2 here it is in the still running status. Thread 3 also it is in the running status. Thread 1. And what about this? So this is the main thread. So totally we are having 4 threads here. So now you can see if I'm going to open this, so it is trying to execute this particular value. But now whenever I'm trying to execute this, so inspect this value. So now you can see it is returning true. So why it is returning true? And earlier why it is returns false? Because all the execution still it is in the run method. Under this particular run method, the thread is in waiting status, because this waiting status we made explicitly. So because of this particular breakpoint here, the cursor, like current thread, is stopped here. The current thread is stopped here. Okay. Same way, now you can see, we'll see the second one. So now you can see second one is also it is returning true. Okay. So now what I'm doing is, if I'm going to run this particular, so basically it is expecting all the three. So this is the second one, and this is the third one. So now all the 3 threads are executed internally, because of the particular waiting states, this particular thread is taken some time here. But now you can see all the join methods are called by the main thread here. But internally, so whatever the join method we call by internally is which is going to wait here, because of this particular synchronization, one by one thread will allow here. At a time, all the 3 threads cannot run by this particular join method internally, because this join method we are not calling. Okay, so this is important, we need to understand here. So basically, whenever we are trying to discuss about this particular multi-threading in the debug mode, so you will get the different expected output basically, because so this is will not depends on any other threads here. So this is we need to understand carefully. Whatever the threads we are having right now, this particular threads is not going to depends on any other one. Whenever we call the start method, all the threads based on this particular objective, the threads are going to be in the running status here. Okay, so when we are calling this start method, basically it is not going to depend any other thread directly. It will call this particular run method. Whatever the logic we are having inside this, it will try to execute here. Okay, this is important, we need to understand. But explicitly, if we want to make this particular current thread to terminate, what we can do, we can go for this particular join method here. Okay, so any questions?
Sir, please correct me if I'm wrong. So if we want to terminate any thread, the first we need to create a object, then with the help of object we can use the join method to terminate that thread.
Yes. See, we have another way also, because if you understand the main thread, what we did basically. So here we did not create it. Okay, here thread dot current thread. So this is basically it will return the current thread. So and here, so which thread is going to execute this line number 16? Main thread here. Okay, so here we don't have an option to execute the particular child thread, and here you can call join method. So this is also which thread is going to terminate here? The particular current thread. Current thread is nothing but main thread only, it will try to execute the code. So whatever we are trying to write here inside this particular main method, so everything is executed by this particular main thread. And here what we are doing here, this particular code is going to executed by the child thread. Now what I am doing here, so I want to terminate this particular child thread. So whenever I'm trying to execute this particular code, so while executing this, I want to terminate. Now what I'm doing here, basically, here I'm trying to create an object. With the help of this particular object, I'm calling the join. Okay, so this is a way of making the threads to terminate here. So here, the whatever the child threads we are having, the child threads are going to be in the terminated status.
So sir, line number 16, like the current thread is main thread. So here 6, 7, 8, there are 3 main thread objects. So according to line number 16, all the main thread, all our...
No. So 6, 7, 8, those are the not main threads. Those are the child threads.
Okay, I'm confused with this main thread and child thread.
Because these objects are created by the main thread. Whenever we are calling this particular constructor, so now you can see carefully again. And here what we are doing here, we are calling super, like we are passing the name of the thread information, and we are calling. So before creating an object of this particular action thread, basically we are giving an option to execute the thread class constructor. Whenever thread class constructor is executed, what happens internally? It will create the thread class object first. So once the object is created, now we are coming back to the extend thread. It is a child object here. Okay, so now here we are trying to create the one child object here. So it's nothing but child thread we are creating here. And once we create the child thread, we are calling the start method to execute this particular run method here. Okay, but this constructor is going to called by the whatever the constructor we are creating, line number 5. This constructor is going to call by the main thread only, because so whenever we are creating this particular main method here, this main method is going to call by the main thread here, and whatever the lines of code we define here, all the codes are going to executed by the main thread, but the same thing, and these sections are going to executed by the child thread. Okay, it's clear. Any questions? Okay, now we'll go to the thread priorities here. So what are all the thread priorities we are having? We need to understand. Basically, in the previous section, we already identified we have a 3 priorities, like within the range we can provide 1 to 10 here. So 1 is a minimum priority, 5 is the normal priority, and 10 is a max priority. So, and if you observe carefully, so whatever the priority we discussed in the last session, this is the third one. And here, these are all the static values. These are all the static values. So here you can see they made as a public. So now what we can do, we can use this particular all the constants. We can make the conditions here. Whenever you are trying to come up with a set priority method, now what you can do, so you can use this particular constants if you want to make some additional conditions, or you can use this particular property in our examples as well, because these are all having public access here, and it is having static access, like directly with help of this particular thread class name, directly we can access here. Getting the point? This is important. We need to understand the priorities here. And what is the use of this particular priority? Basically, internally, these priorities are going to used by the scheduler, and whatever the thread is going to take, like some more CPU memory. Getting the point? So what are all the threads are going to take some more CPU memory? The thread scheduler will give you the highest priority to getting the point. So otherwise, it will go back to the normal order. So whatever the threads were having the order 5, so it will try to execute the one by one. But internally, so everything is going to handle by the thread scheduler. And the thread scheduler, what it will do, based on the thread priority, if any thread is going to take more CPU memory. So why it's going to take more CPU memory? Because because of the highest priority, it's going to do some more activities here. Getting the point? So because of that, the priority scheduler will assign the threads, and the high priority threads are going to execute it first, and later the normal threads are going to execute it here. But everything is going to depends on the here. First one is a thread scheduler, and another one is the CPU memory. Okay, so this is important. We need to understand the scheduler information here. Right now, if I'm going to make the thread priority is also 10, we cannot understand which thread is going to execute, because here we don't have a much code basically. If we are having lot of code, we can easily understand. So the highest priority threads are going to execute it first here. Because of this particular simple code, whatever the simple code we defined here, we could not understand here. So what is the best way to write here? Even now you can see, before going to call this particular join here, I will call thread1 dot set priority. The thread 1 I'm giving as a 10, and thread 2 I'm giving as a 5, and thread T set priority here thread dot main priority. So this is also applicable. Now you can see, because of the particular public and static accessibility, so we can easily access this here. So same thing you can make as a num priority, or you can go for the max priority. So I given static value, otherwise you can go for this particular constraint here. Right now, if I'm going to run the same output here, now you can see, so we cannot understand here which one is executing here. So if you observe carefully, why the output is not printing? So now you can see, first one is executed, second one is executed, third one is executed. So all are in the active status here. Okay, now what we are doing here? So we are calling this particular join method. So the join is holding here because of this particular priority. What happening internally? So the join method is holding. Now the same application still it is running here. Now you can see it is not a terminated here. It is still running here. Okay, getting the point. So this is important. We need to understand here, because of the priority, still it is running internally. Still it is running. So which method is going to stop here? This join method. So once it is stopped here, then only it will go back to this particular tree. And now I want to stop this, because the current thread we cannot make as a join here. Now you can see, because of this particular join, what happening internally, we are trying to make current thread to terminate here, but we cannot make the current thread to terminate. Why? Because we are having below statements here. Whenever we are having this particular below statements here, how we are going to make the current thread to terminate here? So because of that, the earlier it's taken much time here. Okay, now you can see all the threads are in the terminated status here. Getting the point. Now you can see, so what I will do, the first thread, whatever the thread 1 object we are having, I'm going to make here thread dot main priority. Now I'm modifying here thread dot num priority. I'm going to give the second one as it is, and this I'm going to give max priority. Okay, so we'll see the output here. Because of this, first one is executed top one, because we given as a highest priority. So second one num priority, and third one is min priority. So I modified the changes. Now you can see everything is going to handle by the scheduler. So but now you can see, whenever I'm trying to modify this, what happens internally? What happens internally? It is not executed the first one. Basically, this min priority, it should execute last here. Whatever the thread 1 object we provided here, it should execute last, but it is not executing here. Because, so again, what I suggested, First is going to check on the thread scheduler, and the second one is going to execute on the second one is going to wait. So why these objects are in the all are in the num priority only. So now you can see here, whatever the threads we are creating here, all are in the num priority. Like, so all we are having 5 here. Okay, maybe it is not taking this. So what we can do, so this is not the good place to write the priorities here. Whenever we are trying to create an object here. Okay, so here only, before starting this particular thread, we can pause here. Because before starting this particular thread, we can pause. But the problem, whenever we are trying to pause the priority, this priority will affect it to the all the threads here. That priority is going to affect it to this particular all the threads here, because only one constructor we are having, we are trying to pass the same value to all the constructors here. Getting the point? So now, so this is the way I'm trying to call here. Let me execute this. Is there any way to write? No, we are not getting. Whenever I'm trying to modify this priority, all the threads will have 0. Okay. So where I modified here? Yeah, here only I modified here. Why I'm getting this? This priority is not affecting here because thread object is creating the different information. So once object is created, 5. Okay, let me put a breakpoint here from where it is calling. We can identify here. Here I'm going to put a breakpoint here on top of this priority. Okay, now we'll run the same example. We'll see from where this particular 5 is setting. Okay, so this is calling, what is the priority? We are passing as a 5. So let's see, this is, we are trying to create an object here, and it is calling this particular child class object super constructor, and the super constructor, it is calling this, what is the name we are providing? Something like 1 we are providing. The name of this particular thread we are giving as a 1. Okay, internally it is calling the 4 parameters constructor. The 4 parameters constructor. So this is the 4 parameters constructor, and internally which is calling how many parameters? Around 6 parameters. So this particular 6 parameters internally, now you can see. So the thread class internally, it is setting the priority here. Okay, so it is setting the priority. Now, so where it is setting here? Inside the constructor. Okay, so this is the thread object is created. Okay, it is a constructor we are having. So which is expecting 6 parameters here. So inside this, they are trying to set the priority. So what is the priority they are trying to set here? Now we'll see priority, how the priority is loading here. So parent dot get priority. So what is the parent we are having here? How this parent we are getting here? Okay, current thread. So current thread. What is the current thread we are having? Main thread. Because of this particular current thread, the whatever the priority we are having, we are trying to set this priority. So once the object is created, basically, so we need to set the priority. Let's see. Now we are having here. So before going to call only, I made this. So anyway, now I'm trying to hit this. Now I'm trying to pass this name. Child thread I'm printing. That is fine. Now I'm trying to set. Okay, now I understand here. So before going to print this, I can call here. Basically, the priority setting, but we are not printing one more time here. Because of that, basically, what happening internally, it is not. We are unable to see the updated priorities here. We are unable to see because after printing this statement only, we are setting this particular set priority. So because of that, basically, what happens internally, whatever the updated priority, we could not identify here. But right now, what I'm doing is, I'm trying to call this particular super. So the super is executing it, and it is setting the set priority. Now it is coming back to this. So wherever it is calling this, it is identifying it. Now again we are calling set priority. Now you can see what is the priority we provided here. 1, because we are providing as a main priority. Now what you understand? So from whenever we are calling this set priority, it is calling to override the normal, whatever the normal priority, the priority we are having here. So now you can see, so it is printing. So you can see it is 1 priority. So it is nothing but it is calling the min priority. But the problem basically what you need to understand here, whenever we are trying to creating an object, each and every object it is trying to set the same priority here. Okay, it is trying to set the 3 priorities here. This is the way all the priorities are executing, and finally we are calling the join method to terminate this particular current thread here. Okay, this is important. So otherwise what we can do, so here only we can call set priority. But here now what I'm trying to provide on top of each object here, thread dot, so I want to provide, sorry, so main priority. But now what you need to understand here, the priority basically what is returning here, it is a void here. Okay, so this is not also suitable way of setting the priority. And here now what I understand here, we can remove the start from here. From here we can remove, and here whatever the set priority we are having, the set priority also I am trying to comment out. So why I am commenting this, basically we need to set property for each and every object separately. Now if you see here what I am doing, it I am having 3 objects. So I am trying to enable these 2 and set priority and thread 1. Okay, main priority, and here thread 1 dot start here. Instead of calling the start from the constructor, now what I'm doing is I'm trying to call from the main method. Okay, whenever I'm trying to call this, now what happens internally? Internally, it will try to call this particular constructor and it will set the priority. So we'll see what are the priority we are setting to the each and every thread. Let me run this example one more time. So num priority. Okay. So whenever, so this also we need to print here only. This is also not applicable basically, because this extend thread is called by the main thread, and main thread internally we are setting as a priority 5, and the same priority we are printing here. Okay, but explicitly here what we are doing is we are trying to modifying the priority here. So this is nothing but thread 1, so thread 2 and 3. Okay, so these are all the three threads I'm trying to printing explicitly from outside of this particular method. Now you can see all the threads are modifying here. All the threads are modifying. But now what you need to understand here, so which one is the highest priority here? Third one. Getting the ball. So whatever the third thread we created, which is having highest priority. But even though it is executed last year, even though it is executed last. So now again, I'm trying to run one more time. Now you can see what happens internally. So first one is executing. So second as a third thread is executing, and second one is a last thread here. But the priority is affecting here. So each thread we provided as a different priority. But what happening internally? So here it's going to take based on the CPU memory time. So which is going to take more CPU, then the particular thread is going to take highest priority here. Here we are having same memory is going to executed by the each and every thread, because we are having same code we are trying to execute here. Okay, but what we need to understand, we can modify the priority with help of this particular set priority method here, and everything I'm trying to create from the main method. Okay, so this is important information we need to understand here. Any questions regarding this particular set priority? Okay, so now we'll see synchronized keyword. Basically, how this particular synchronization is going to work here. When we are trying to execute multiple threads, whenever we are having multiple threads. So same way, how many threads we are having here? 3 threads. Whenever we are trying to execute more than one thread here, we are going to get different output here. Okay, so in order to pass one by one, in order to execute the one by one, what we are doing basically, we'll use this particular synchronized keyword here. So first we'll see if I'm not using the synchronized keyword, what is the output we are going to get, and if I'm going to use the same synchronized keyword, and what is an output we are going to get here. Okay, so let's understand the simple example so that we'll get to know the advantages we are going to get whenever we are trying to use the synchronized keyword. And what is the name of the class I'm trying to create here? Something like call me. And now you can see this particular call me internally it is having one call method. Okay, and is expecting one message property. Getting the point. Internally it is expecting one message here. So what you need to understand here, I'm going to print here the print statement I'm trying to write here, and internally I'm opening one brace here. Okay, the array type bracket I'm opening here, and after this, now what I'm doing here, I'm adding this particular message. So after adding this particular message, internally I'm trying to use a try statement. Inside this particular try statement here, now what I'm doing is thread dot sleep we already identified. So I'm going to provide something like 2000. Why I'm giving this particular 2000 basically? So it's going to take little more time. We can easily understand the output how it is printing. Okay, so understand here after this particular try, I'm trying to add catch here, interrupted exception and EX here. So after this particular EX, we can print here. So if you want to print anything, So we don't need this println segment ex dot print stack trace basically. And after this particular catch block, I am trying to add close brace. Whatever we define the particular close, the array type is. So observe carefully. Here what I'm doing is, I'm trying to use the print statement and I'm trying to add one string here. The string basically it is it is going to print the array type bracket here, and internally it is contain this particular message, and once it is completed it will move on to this particular println and it will close this. Okay, we are opening and we are closing. In between we are trying to add the message. In between we are trying to add this particular message here. Okay, now what I am doing here, I am going to create a one more class basically. So this particular class will contain the thread object. What is the class I'm trying to create here? Something like a caller. The call me method call me class we define. Now I'm defining caller. So this caller, what happens internally, it is going to implement from the runnable interface and will override the unimplemented method called run method. Okay, and here so string message I'm passing per one parameter, and the second parameter one call me target object here and thread t. Okay, so these are all the three parameters. Now what I will do, I'm going to create a constructor. The constructor should be public here. We cannot make as a private here. So first parameter call me, and I'm going to pass as a string message here. Okay, so two parameters. Now what I'm doing here basically, so this particular target is equals to call me, and this dot message is equals to message. Okay, now here what we will do, we'll create an object. So t is equals to new thread object here, and what are the parameters I'm going to pass here. So here you can pass the current object. Just I'm passing the current object t dot start method. Okay, so using this we are going to start the particular, which one we are going to call thread here. Okay, so now finally inside this particular run method, simply target dot call, and here I'm going to pass message. Okay, inside the run method I'm not doing anything, just I'm calling the call method. So which call method I'm going to call? The call method just we defined inside this particular call me, and this particular call method is going to call. But here what we need to understand here, how many threads, like how many objects we are creating this, how many objects we are going to create, all the objects are going to call this particular call method here. Okay, this is important here. So right now, so what is the main class we can define? Call me caller, and call me caller main. So the main I'm enabling this. What happened? Okay, so this is the main class here, and once we define this particular main class, first what object we need to create? Call me object we need to create. Why we need to create call me? Basically here, call me is expecting caller object here. Okay, so this is the caller 1, caller 2, and caller 3. So caller 2 and caller 3. Three objects I created, and the three objects will contain the different message. So hello. Here I'm going to modify the different message. synchronize, something like world. Okay, so these are all the three objects I created. Now what I am doing basically, what I will do, so I'm not going to do anything here. So simply if I'm going to run this, so what is the expected output basically? Now you can see, so this parameter, the bracket like array type bracket is open here. So message is added and one more bracket is added, one more message is added, and one more bracket is open and message. But what we are expecting is, so this is the expected output basically. It should enable and add the string message and it's close. So later it should enable, add the message and close. Getting the point? So we are expecting the output like this. Getting the point? So this is the message. Okay, and this is the one more message, and this is the one more message. But now you can see the output how it is printing here. So whatever the expected output, it is wrong here. Getting the point? It is wrong here, right? So here we are having hello and synchronized and world. So again it's closing extra to this particular brackets here. Getting the point? So now how we can achieve this? First here, why we are getting this output here? Because so it is not working on the one by one. At a time, this particular threads are going to execute here. But we don't want to execute this at a time here. We want to execute one by one. Now you can see what I'm doing here. I'm going to make as a this particular synchronized keyword. So carefully observe here how this particular synchronized keyword are going to execute here. Wait, yeah, here only. So synchronize void call method. Okay, now I'm going to run the same example. Now you can see, so how we are expecting the same way we are getting output or not. So it is having one array open braces and close brackets here and between string message. So now you can see same thing. One is closed, so second one and third one. Same way you can see all we are getting same. So why we did not get earlier? Why we are getting now? So what is the purpose of this particular synchronized keyword? Basically, synchronized keyword, what is doing here? It is stopping here all the threads here. So it is allowing one by one here. Getting the point? So whenever we are having multiple this particular threads, whenever we are trying to execute here, if we want to execute one by one, so what we are doing is we are trying to use a synchronized keyword here, but internally all the threads, like whenever the current thread is executing, the remaining threads are going to be in a waiting status here. Getting the point? Remaining threads are in the waiting status. So once the current thread is completed, then only the other threads are going to execute here. Getting the point? This is important here. Okay. So any questions regarding this particular synchronized keyword?
Sir, if first thread is running, the other two threads will be in the waiting state. Is it in the synchronized concept?
Yes, exactly.
Okay.
This is synchronized concept. It's running little late, or like we are using the sleep method that also working.
No, it's not going to use the sleep method. Basically, it will try to use a locking system. So whenever we are calling this particular call method, so here whatever the lock internally, it is going to lock here. So whenever it is locked here, if you are trying to access multiple threads by this particular same call method, it will not enter here. So once this particular lock is released, okay, when this particular lock is released, whenever it is coming out of this particular call method, the lock will release. and whenever the new thread is entered into this particular method, again, so we are going to make lock-in system. And internally, the current example, we are making the sleep also. So it's going to take 2 seconds to sleep here. So all the operations will complete it, the other threads. All the whatever the other threads we are having outside, all the threads are going to be in a waiting status here. Okay, so the once this lock release, one thread will enter, and again remaining threads are in the locking status. Because once the lock is released here, now what happens internally? So here we have an option to enter all the threads, but here because of this particular synchronize here, only one thread is going to enter here. Getting the point. But here the one drawback basically, whenever we are trying to use this particular login system, so we are going to get less performance here. So because explicitly we are making the threads to sleep here. Like we can call it as a waiting here, not the sleep here. Explicitly the threads are going the waiting status here. Because of this particular locking mechanism and because of this particular synchronized keyboard, we are going to allow only one thread at a time here. Okay, so most of the cases we are not going to use here, and we'll come up with we have a different framework that is called executor service. The executor service will do these particular advantages because of this particular synchronization. We'll get the performance is low. Okay, so instead of using the synchronized keyboard, what is the best way of writing? Something like executor framework here. So this is the another big topic here, so we are not going to discuss here. But if you have a time, just go through the executor service, how it is going to work internally. So same way how we are creating these objects here, same way how we are creating this particular object internally. So there we can provide the how many threads we want to create. So just we can provide the number of threads here, and internally everything is going to handle by the executor service. Okay, so this is the alternative way of handling our multi-threading using this particular executor service here. Okay, now what I will do, I will move on to this particular another important topic called so inter-thread communication. How this particular inter-thread communication is going to happen whenever we are having multiple threads. Okay, so as I explained here, if you go to this particular object class, what is the object class we contain here? This is the object class we are having here, and I'm going to open this particular method section. Now you can see, so what are all the methods we are having here? Here we are having this particular, first one is notify method, notify all method, wait method, and wait is expecting internally. First one is the long, and one more wait is expecting internally, long comma int here. Long comma int here. Okay, we'll see whether this method we can access outside or not. Now you can see this method also we can access from the outside. And what is expecting? First one is timeout milliseconds and nanoseconds. You can provide the nanoseconds along with the milliseconds. Okay, so if you are not interested to work with this particular method, what is the another one? This is the another one, wait, which is expecting only one parameter, that is called long here, like milliseconds. So most of the cases will use this particular wait method. Now what are all the another two methods? So one is a notify and notify all method. So we'll see how this particular wait and notify all methods are going to use to communicate multiple threads here. So this is, we'll call it as inter-thread communication. Okay, so wait method basically what it will do, it will try to wait the thread until the time is completed here. Okay, but here the problem, when the current thread is in the waiting status, so the waiting thread is going to notified by the one thread here. Getting the point? The current thread, if it is in the waiting status here, the waiting thread, it needs to waitify, like it needs to notify here. So otherwise still it is in the waiting status only. But what about this particular sleep method? Sleep method, whatever the time is completed, automatically it will come back to the running status. But wait thread, the wait method, whenever we are calling this particular wait method, the thread will not coming automatically to the running status. So we need to notify the thread. Getting the band, this is important here. So basically, simply I will show you the diagram how it is going to look like here. Now you can see this is the cycle of this particular thread here. So here it is a ready, and here we are trying to running this thread here, and it is in the waiting here. Okay, it is in the waiting status. Now whenever it is in the waiting status, so when we are using the sleep method, so here we have a sleep method, we can call the wait method, and we can call the join method. So these three, they are going to call in the waiting status. What happens basically, so whenever we are calling this particular sleep, we'll provide the time duration. Okay, we'll provide this particular time duration. So whenever we are providing this particular time duration, once the time is completed, automatically it will move on to this particular running status. Automatically it will move on to this particular running status. But what about the waiting here? Whatever the wait method we are going to call here, so even if you specify this particular time here, getting the point, even if you specify this particular time, what happens internally? What happens basically internally here, we are going to specify the time. Once this particular time is completed, now this thread, whatever the thread is in the waiting status here, so this particular thread, it needs to notify here. Okay, someone it needs to identify your time is completed. So once it is identified only, it will move on to this particular thread into the running status. Otherwise, so whatever the thread is in the waiting status, still it is available in the same year. Still it is in the waiting status here. Okay, this is important, we need to understand here. The differences between sleep and wait. The wait is going to identify, like it's going to notified by the some other threads here. Okay, so that information we are going to discuss now. So let's have a simple example how this particular threads are going to execute here. Now what I am doing here basically, so we are going to discuss about the one of the important information here, something like we'll discuss about the stack example. Otherwise we'll create a one more stack only here. This particular stack cannot have more than one value. So we are not going to insert multiple values here. So simple value we are going to insert here. And now you can see private into n here. Getting the point. So now what you need to understand here. Here I'm going to write the get method, and here I'm going to write the put method. Okay. So let's see. Sorry. Synchronize keyword I'm using, and here I'm going to use get method. Okay, so this method, the get method will contain this particular messages only we are trying to print the message, something like get method. Okay, and here what I'm doing is I'm going to print n value, and here return n, and this is the get method. And the same way synchronize, and here I'm having void method, and I'm going to use put method, so which is expecting int n here. Getting the point. And here also I'm going to print this particular okay, I'm setting the value. So this is the simple example we created, something like a stack here, and this particular stack basically what it will do is going to implemented by multiple classes here. Okay, first one is producer. So this producer, what it will do, this particular producer, it will implement the runnable interface, and we'll try to override the particular run method. And here stack example. Okay, so the simple example I'm trying to take as a parameter. Now, what happens internally? So what happens internally? This producer, I'm making the constructor, and for this particular producer, I'm going to pass as the particular parent object. Okay, so now you can see this dot stck is equals to stck. Okay, after this, now what I'm doing here? I'm going to create a thread object here. So by specifying this particular first parameter and the second parameter, producer. The name of the thread what we are providing here, producer. So after this, let me make T as a capital. Dot to start. At a time, I'm making all the operations here. Getting the point? I'm creating an object. Once object is created, based on the object, I'm trying to call the thread. Okay. So what is the name of the thread I'm giving? Something like producer. And internally, what I will do? Internally, what I'm doing here, I'm trying to provide the information here. So inside this particular run method, because whenever we are calling the start method, what happens internally? It will call this particular run method. Okay, it will call this particular run method here. Okay, so this is important. We need to understand. And I value 0 I'm making, and I'm going to use a while loop. Inside this particular while loop, I'm making true. Getting the point? Now, stck dot what method I'm calling? Put method I'm calling, and by providing this particular I++. Getting the point? This is important. We need to understand here. So observe carefully. We are having the producer class. The producer internally we are creating one specific thread here, and the thread internally it will execute this particular while loop to initialize the multiple values. To initialize this particular multiple values. Okay. Now this is I'm making, but if you see the while cannot have a condition. So we'll see how it is going to execute this example. And one more example. Like it's like a one more class here. So first one is a producer, second one is a consumer. Okay. So now the consumer is also internally is implements from the same runnable interface, and will override the same example like same run method, and finally this will also same. Consumer constructor. Okay. So this is I'm passing, and after this, so same thread I'm going to create here by passing these two parameters. First one we are passing as a current object, and the second one we are going to pass as a name of the thread. So something like consumer. After this, we'll try to call the same start method. Now we'll move on to this. And now what I'm doing? Internally inside this particular consumer, so what I'm doing here? And here, simply I'm going to make one while condition. I'm making the true, and stck dot get. Because the get method will do the print statement. I think we don't need to print this, because internally we are trying to print this particular get here. Okay, so the get will print all the values. Now what you understand here? Now what you understand here, every time the condition will start. Every time the condition will satisfy here, either this particular condition will satisfy, and inside this particular producer, whatever the condition we are having, the particular condition is also satisfied here. Okay, this is important. We need to understand. And now what I will do? So we'll go to the main class. So where we created, again we'll come up with the one example. For the main purpose, P and Q main. So producer, so not a Q, it's a C. Producer consumer main here. Okay. So inside this particular PC main, now you need to answer my question. How many times this particular objects are going to create? So when this particular the loops are going to terminate it here. Okay. How many loops we define basically? Two loops we define basically. But now what we need to understand here, that what time, like how many times this particular loops are going to repeat it, and when it is going to terminate when this particular loops are having condition fail here. Okay. So this is important here. How many times the particular loops are going to repeat it, and at what time the condition will fail here. Now if you observe carefully, first we need to create a stack here. Why we need to create this particular stack here? This is the main object we are passing into the two objects here. First one is producer, something like so this is the stack I'm passing. Consumer. Okay. Now I'm not doing anything here. Simply I'm going to run this example. So see the output here. It's keep on running. It is keep on running, but there is no condition to stop here. Why there is no condition to stop here? So I'm going to stop, because what is the condition we are making here? The condition we are making here true. Every time we are making true. So where we are making the true? Getting the point. So now if you observe carefully, inside this particular while loop we are making the true, and inside this particular producer again we are making true. So now you can see the value, it started with 0. So what is the last value? So this is the last value, 1227568 here. But what we need to understand, but this is run by the get method. So now you can see how many times the get method is calling here. So the get method is called multiple times. Now we need to see, so meanwhile the put also will call multiple times. Where it is? This is internally you can see somewhere we are having put. So this is the put operation. It is trying to modify 93, 94, 95. So 500, 507, 508. Now you can see up to, still these are all the put values. So 568. Whatever the 568 we are having, so this is the last value, and this last value is loaded by this particular get method. But still, it is still running an example. So this is not the expected behavior. Getting the point? Now, whenever we are trying to run the multiple threads, like it is like one method is trying to insert the data. Getting the point? One method is trying to load the data. But the problem for inserting, we are using one thread here. For getting purpose, we are trying to use one more thread here. Okay. So we need to make the relation here. Whenever we are trying to use this particular kind of example, we need to make the relation. So whenever we are making the relation, what happens basically, one thread is inserted. Getting the point? The information is going to share it by the another thread, so that the another thread, what it will do, it will try to load the data. Okay. So once a thread is loaded the data, again another thread, what it will do, it will try to insert the data. Okay. So this is a way we can insert the data and we can load the data. But how we can provide the information to, so this particular two threads here. So this is important, we need to understand here. Okay. So let's see how we can provide this particular information here. So now to provide this particular information, we are going to use whatever I discuss here, like a wait method and notify method. Okay. So observe carefully. Here I'm going to use this particular, so same class. Where is this particular stack? This particular stack only I'm going to use. And inside this particular stack, now what I'm doing here I'm going to provide value set I'm making as a false. Okay, by default, the boolean value I'm making as a false. Now what you need to understand here, inside this particular get method, again I'm going to use this particular while loop, and here I'm making the not condition. I'm making the not condition. So inside this particular not condition, now what we can do, I'm going to use try block. Getting the point? Inside this particular try block, I'm calling wait method. Getting the point? I'm calling wait method. Now if you observe carefully, so I'm going to use the catch statement. So we already identified which exception is going to get, something like interrupted exception. And once you get this particular exception, now so simply I'm going to print this particular message. So if you get anything, this exception will trigger, and I'm going to print this. Okay. After this, now what I'm doing here, I'm going to print this particular get value. But where I'm printing? Outside of this particular loop. Outside of this particular loop only, I'm trying to print this particular get value. And here, now what I'm doing here, value set, again I'm making as a false here. And here, notify method. Okay. So observe carefully. Now I'm calling wait method. Again I'm calling, getting the pen, notify method. Okay. So because of this particular wait and notify, we can easily share the information to multiple threads here. The same logic I'm going to pass into this particular put method. The same logic I'm going to put into this particular okay. So try I'm making, and here we are giving an option to initialize here. I'm not using the not condition here, but what we need to understand here, after this value set I am going to make as a true. Getting the point? And so here also we need to call the notify. Okay, so observe carefully, notify and wait method we are using, and internally, so what we will do, we'll do the same, the remaining whatever the while true we used here, we'll try to come up with the same here. Okay, so the same example we are going to use, but only here I'm going to add a condition, like a not condition, like a println statement I'm going to add. So press Control plus C. Okay, and why we are adding this particular message, and because the while loop still we did not provide the condition. Getting the point? Still this, but the while loop we did not provide the condition. It will try to keep on execute, but whenever it is trying to keep on executing here, we'll get the expected output. First it will call the push method, later it will call the get method. Okay, so let's see. So here I'm trying to run the same example one more time. Okay, now what happens internally, if I'm going to stop this, now you can see how it is executing. So what is the value the put method is inserted here? Something like 194,673, and the same value is getted by the get method. Now you can see here put method 194,666 is inserted, and the same value is loaded by the get method. Now what do you understand here? So first it is executing by the put method, the same value is loaded by the get method. So once it is loaded by the get method, now the next thread is trying to insert here. Okay, so this is the operation. So this is, we are having put value. First, the put method is calling. Okay, the value it is inserted here. Once the value is inserted, the get method is trying to load this value. So once the value is loaded, nothing is available. Okay, nothing is available. What happens here? So again, one more thread. Okay, because we are inside the loop here. So one more thread. The same thread, basically, the one more value is trying to initialize here. So same, one more thread is trying to load. Okay, one more thread is inserting. One more thread is loading. Getting the point? So here, one thread is inserting. The same value is loaded by the another thread. Once it is completed, one more thread is coming to insert the value. Getting the point? So here, the output we can see here. So this particular output will give you the information here. Okay, how it is giving? So put method is inserting the value. Same get method is trying to load the value. So now we can compare any value. For example, here you can see put method 787, same get method. So 788, 788. So now you can see 794, 794. Getting the point? So each and every operation is having internally depends on this particular two threads. One thread is inserting the data, the same value is loaded by the another thread. But how it is happening internally? Because of this. So see the code what we implemented. So whatever the value we are having, first we are making the value set. What is the value set value? False we provided. Whenever we are providing this particular false here, this condition will be true. Okay, this particular condition will be true. Now what happened internally? This current thread, now it is moving into the waiting status. So once the current thread, now it is moving into the waiting status here. So this thread, it should notify. Okay, this particular thread, it needs to notify here. So which method is going to notify here? So here we define the notify method this. Okay, so this notify method will not call here because already the current thread, whatever the current thread we are calling this particular get method, now it is in the waiting status here. So again, the same thread, it is not going to call by this particular notify here. So here, which thread is going to notify here? Another thread here. So another one, what it will do, it will try to insert this here. So what we are making a value set as a, what is the initial value? Something like false here. This condition will not satisfy. Whenever it is not satisfied here, it will come to this and it will print this value and it will call the notify. Whenever it is called this particular notify, what happens internally? Now this will come out of this particular rail method and it will call the all the information. Okay, at the time of calling this particular notify, at the time of calling notify, what happens internally? So one more request will enter. One more request will enter. Whenever the one more request is entering into this, so the current thread will into the wait status and the information is going to notified by the notify method here. Okay, so this is the way the inter threads are going to communicate each other here. Okay, this is the way the inter threads are going to communicate with each other. Any questions regarding this? Any questions regarding this particular inter thread communication example?
Sir, can we use the synchronized to the run method, sir?
So run method, basically we are like, if we observe, where is that? Here only, not consumer producer. So what happens here? I'm going to use a synchronized keyword because this is the specific method we are writing internally inside this particular producer class. Okay, so again, when you are trying to run this, we need to create an object and then only we can call this particular run method. So for example, I will write here. Okay, now I will run the same example. So I will stop with this. We'll see what happening internally. So here 7685 and we'll try to identify the one value, same value. Put method 617, 617, 618. Okay, so here, but I think this is not using here. Now what we need to understand basically, how many objects we are creating? Only one object we are creating. So if we are calling this multiple times, so for example, the producer I'm going to call multiple times. Where is the PC main? Here, second time I'm calling. But the problem, this will not execute because of this particular multiple condition what we are having. Okay, so this example we can see in the one more example. Okay, let me remove here. This is not the correct way of writing here. The this particular two example will internally is trying to execute multiple times because of the particular while loop. So what I will do, we'll go to the another example. The another example here we can discuss. Call me. How many objects we are creating here? Okay, here we are creating a multiple objects here. So we'll go to this particular caller, and now what I'm doing is I'm trying to call this synchronize keyword. Okay, so whenever I'm calling this particular synchronize keyword, so we'll go to the call me here. So this I will remove. Okay, here I'm reviewing the synchronize keyword where we used in earlier inside the call me. Now we'll go to the same example, call me caller main example. I'm running this. Okay, what happening internally? We are not getting the expected behavior. Basically, it should get the expected behavior. Why we need to get the expected behavior? Because here if you see how many objects we created, 3 objects we created. So each and every object internally, so this is the way of creating a thread object, and we are calling the start method. Whenever we are calling this particular start method, what happening internally? So this the synchronized keyword, and internally it will try to call this particular call method. But observe carefully. So this caller is going to call by the which thread here? Getting the point? This particular caller is going to call by the which thread here? Basically, it is going to call by the main thread. So how many main threads we are having here? Only one main thread. Now if we go to this particular call me caller main, one by one operation is performing here. Okay, first the line number 7 will call, and later line number 8, and later line number 9. Getting the point? So if it is calling one by one, why we need to use the synchronize? Getting the point? But the synchronize keyboard, what it will do? Whenever we are calling at a time, multiple threads here. But here we are not getting the at a time here. Only one by one we are getting. So the problem, even though if you are using this particular synchronize, inside this, even though if you are using this particular synchronize here, we are not calling the multiple threads at a time to this particular run method. Okay, so one by one we are calling. Getting the point? But problem basically, this method, this particular call method is going to call multiple threads here, because here we are creating the multiple objects here. Here we are creating the multiple object with a different information, and the different threads are going to call this particular run method differently. Okay, so later this call is going to call multiple times. Now you can see, so one thread is calling this and one more thread. So even we are not getting the expected. If it is calling one by one, if it is calling this one by one, we should get this whatever we have seen earlier. So now you can see, if I'm adding the same synchronized keyword to this, now if I'm going to run the same example, getting the point. But if you add the same keyword to the run method, there is no use. Getting the point? This is important, we need to understand. So we cannot add, like we can add, but there is no use. But the problem, wherever we are calling the specific method is going to executed by multiple threads. So those information we can make synchronized here. Okay, is it clear?
Okay, sir. Yeah, clear.
Okay, now deadlock situation. So deadlock situation is basically one thread is depending on another thread. Okay. So now the simple example I will provide, but we cannot write this kind of example. So now if you see, we are calling put method and it is a synchronizer. Okay. Now internally what I'm doing is I am going to call the get method here. I'm call this particular get method. So for example, it is started with a 16, something 17. We are doing this different operation, and the line number. Okay. This line number, what happened? Okay, the line number 80. Now I'm calling this particular get method. Okay, so line number 19, we are doing some other operation. We are closing. This is the put method. So I'm writing here get method. Get method is also synchronized here. So you can see, so some lines of code we define here, and line number something like a 15 or something like a 25. Again we are calling put method. Again we are calling put method. This is also one more synchronized method. So now if you see, this is the synchronized put method. Internally we are calling the get method. Now this particular thread, it will try to execute this get method. What happens internally? One more thread is came. One more thread is came, and this is also synchronized here, and internally we are calling put method. This put method, it is trying to execute this. So whenever we are calling like this is basically deadlock situation. Now what happens internally? One thread, first thread, okay, this is the first thread for this particular put method, and this is the first thread for this particular get method. Now observe carefully. First thread we are calling the put method. We executed few lines of code. Now it is called the get method. Okay, so whenever it is called the get method, what happens internally? So one more thread is already is trying to execute. Okay, so one more thread is already executed here, and it is execute the few lines, and it's trying to call the put method. So now carefully observe, because synchronize keyword internally, it's going to use the locking behavior. Already one thread is already executing, and here also one thread is already executing. Okay, and whenever it is executing here, what happens internally? The each and every thread is trying to execute the other operations. So when you're calling this particular get method, because already this get method is executed by this. Okay, this from your line number 18, we are calling the get method. The already one thread is trying to execute the get method. What happens internally? We locked here. Okay, we locked here, so we don't have an option to release. When the lock will release, whenever it is trying to come out of this particular get method. But when it will come internally, what we are doing is we are calling the put method. So put method is already locked here, because one thread is already enter. Okay, so here this particular lock will not release. This particular lock will not release. Okay, so what will happen here? Can you happen? So basically, this kind of situation, we'll call it as a deadlock situation. And here, the deadlock situation, we cannot write here. Okay, so this is very, very important here. So just I'm providing the information. So it will stop here. It will not go anywhere here, because here the put method is expecting to release the lock, and the same way get method is also expecting here release the lock. But how it is going to release the lock? Because all the methods internally it is calling here. Already two threads are entered. The two threads are internally calling each and other methods here. Okay, so this is I'm giving an information. We are not going to create any application like this, because we are going to get deadlock situations here. So this is just I want to provide the information here, how this particular deadlock situation is going to work internally. And now we need to understand the particular state of this particular thread here. So how we can understand this particular state of this particular thread class here. So now you can see, so as I explained, I'm going to provide the same, the circle here. Now this is, we'll call it as a new, we are going to create this particular object here. So it is going to start the thread here. Thread will start here. Okay, whenever the thread is going to start, what happens internally? It will move on to this particular. It will move on to this particular running here. Okay, otherwise we can make running inside here. Okay, this is running from starting to directly. It will move on to this particular running, and now what happens here? Waiting here. Okay, so waiting here two types here, without a time here, and one is a timed waiting. Timed basically sleep method. Okay, this is important. Now what happens internally? Once the time is completed or waiting time is completed, now it will come back to the same running status. Okay, so once the running is completed, now where it will go? Terminated. Okay, it will move on to the terminated. And if we have blocked here, getting the point. So if something is blocked here, because we are giving the option to execute some other threads, like this particular blockade will work on the synchronize here. Okay, so once a blockade is completed, what happens internally? It will come back to the again running state. So observe carefully from wherever you are go. Either you are coming from the blockade, or you are coming from the running. Sorry, you are coming from the initial state, or you are coming from the waiting state. So all the three steps. These are all the whatever we created this. So first one blockade or starting or waiting. Everything internally it is depending on the running. Okay, so if I'm not providing any waiting or block to directly, it will go to this particular terminator here. Okay, this diagram will give you the more information about the thread life cycle basically. Okay, so it will start from the new. Now it will go to the running state, and if you are trying to wait something, it will go to the waiting state, and once the time is completed, it will come back to the running state. And if you are blocking something, if you are trying to block something, it will go to this particular blocking state, and it will come back to the running. Finally, it will go to this particular terminator. Okay, this is very important. We need to understand the life cycle of this particular thread here. Okay, so any questions?
So start this join method. So will it permanent delete that thread or just stop that thread?
So basically, join here, it will turn, basically it will do the two operation. So here it will come back to the waiting state. From the waiting state to directly it will go to this particular terminator here. Because forcefully what we are doing is, forcefully the join method internally, it will try to terminate the thread here. So whenever, if it is in the running status, now thread will go to the waiting state, and from the waiting state, it will try to terminate the thread. So once it terminated, it will come back to this particular state here. So otherwise, directly we can call basically here also it will work, the join method. Now running the thread, whatever the running thread we are having, whenever we are calling this particular join method, it will wait here until the current thread to terminate here.
So my question is, this join method work is like permanent delete or just stop?
No, it will terminate is nothing but permanent delete only. It will not stop here.
If you want to retrieve that values.
No, the thread once it is terminated, you cannot get.
Yeah. Okay.
So that's the reason I'm providing you. So stop is different because the waiting is nothing but a stop here. Here we are stopping the thread certain time here. Once the time is completed, we are coming back to the running state. So here the objects are not available here. Okay, so whatever the object we are having here, so those objects are not available here. So that's why I'm calling here terminated here. Okay, any other questions? Okay, so if we don't have anything, now tomorrow we'll discuss about the auto boxing and auto unboxing, and we'll come up with annotations example. Okay, so tomorrow also one of the important example we are going to discuss here, how we can convert one data type into another data type here. And if you are trying to create a custom object, so those objects also how we can convert here. So this conversion related example we are going to discuss here. And later we'll create a annotations here. So this annotation will give you the more information in a like advanced technologies, like if you are trying to use the Spring or microservices, any technology, so you can easily understand the purpose of this particular annotation, what it will do. Okay, so those information we are going to discuss in the tomorrow session.
So tomorrow's class also part of the thread?
No, thread is completed today only.
Okay.
Okay, so we'll continue tomorrow. If anyone having any questions, you can ask me what we discussed so far. So tomorrow, as per the IST, it is 7 a.m. Okay, so we'll continue tomorrow.
Okay, thank you, sir.
Okay, thank you, sir.